Hi everybody, welcome to the fifth Kryptos video I've made. I thought it was a good opportunity to get in ahead of the end of the auction and talk about what's been happening since the last talk. So, history lessons to begin with. In 1990, a cryptography expert published a challenge cipher of approximately 100 letters. The algorithm he used to encipher the plaintext was publicly unknown and deliberately withheld. He did disclose, however, that the plaintext was in the English language. And despite the best efforts of amateur and professional cryptanalysts, nobody was able to decipher it for decades. As the creator had never gone back to check the encipherment process himself, nor had a third party done any checking, people began to suspect an error had been made or the cipher was not reasonably solvable. Then, more than 20 years later, a researcher whose goal was not to crack the cipher, quote unquote, visited a Washington DC area museum to read about the cipher, and he discovered the plaintext in a museum archive where the creator had left it some time before. The creator hadn't intended the plaintext to be revealed in that way. Of course, I'm talking about the Chaos Cipher challenge of Louis Crew and cipher a device from Cryptologia in 1990. What were you thinking about? So Patricia Byrne, the daughter-in-law of the Chaos Cipher creator, John F. Byrne, deposited the Chaos Cipher papers in the National Cryptologic Museum in 2010, and Jeff Kaloff decided to visit the museum in May 2013 and discovered the challenge plaintext from 1990. So why was nobody able to solve it? Now John Byrne, the creator of the cipher, Chaos Cipher, said that perfect accuracy was essential when enciphering a message, because if you made even one error, it would distort the rest of the cipher. And his son, another John, explained to these two cryptography experts how it worked in 1990, and in the paper where they wrote the challenge ciphers, they said this shortcoming of the cipher would be eliminated by implementing it on a computer, which they did. But despite that, in the publication process, obviously something went wrong, and in 2014, in a paper about the solution of these challenges, the authors said, did the authors of that challenge really play fair with their audience? And they concluded that if anybody trying to crack the system didn't understand how it worked, then the likelihood of a solution being found was practically nil. And William F. Friedman, one of the most famous American cryptologists, always emphasized in his writings that the formation of letters was very important. Roman capitals should always be used, and grid paper, and using ink and carefully made Roman capitals. Okay, but what happened in Chaos Cipher? Well, we got U's and V's confused somewhere in the publication process, and also D's and O's got confused there in another message. And if you look at, for example, this worksheet up there, that's Jim Sanborn, the creator of Kryptos's recently revealed worksheet for some of the Kryptos messages, and we can see already, you know, there's a lot of errors in the encipherment process. Illusion, underground, Langley is misspelled, desperately is misspelled twice, even 40 has been misspelled. So it doesn't really, fill you with confidence that the process has been carried out correctly. So, updating the timeline, what we see is in 2025, in May, my Histocrypt paper with Louis Helm on solving 22 and 24 letter Playfair challenges was published in the proceedings. I had a lot of help with Louis with English language statistics, letter and word statistics. At the end of May, on the Kryptos Group's message board, the CIA coded ceiling challenge was given, a URL on the CIA website, and over the next 10 days I posted the type of that cipher and the solution in the group, and you can certainly search for that on the group if you would like to know how it worked. The next month, the Harvard Library Public Domain Corpus was published. That's basically 1 million books in 250 different languages, and it's a lot bit bigger than the Books 3 corpus, which is about 200,000 books, and Project Gutenberg, which is about 60,000 English books. So Beijing House's language statistics are based on 10 terabytes of data, and they are statistics from 1 grams, that's single letters, up to 10 grams, that's groups of 10 letters. And they're great files and I use them all the time, but it's not exactly clear what the source of all the input data was. Whereas if you use this, anybody can download it and they can choose languages to generate statistics from. Okay, and in August, William Webster, who was the director of the CIA at the time of Kryptos, died, and very soon after that, Sanborn announced his auction plans. And so Webster is one of the few people who's known to have seen the K4 plaintext, and there are a few comments on it there that he made. It was philosophical and obscure. He talked about some of the plain text being in blank verse. The other 3 sections that have been solved in Kryptos aren't blank verse, so presumably he's talking about K4. Maybe some iambic pentameter is involved. And then, you've got Sanborn himself saying the final passage leads in several directions and what's the point, and things like that. In August, the government attic updated the NSA Kryptos Society newsletters, but I didn't see anything particularly earth-shattering in new revelations there. At the beginning of September, Jarrett Quebec and Richard Byrne found the K4 plaintext at the Smithsonian, and it was said to be 5 sheets of dozens of squares filled with letters. I had talked to the Smithsonian in 2020 to get the 6.5-hour Sanborn oral history interview released, and I did a Freedom of Information request for the GSA contract for the original Kryptos, but that didn't lead anywhere. So I suppose other people were thinking about asking the Smithsonian for that, and it was really a matter of whoever got there first and saw those pieces of paper. They would have had a good chance of finding the plaintext themselves. In the last few months, there's lots of coding charts posted at the auction site and on the Smithsonian webpage. There was a press conference a few days ago at the Spy Museum in Washington, D.C., where Sanborn said the Berlin clock in the K4 plaintext is the Alexanderplatz clock. There's a picture of it up there where the big demonstration was in November 1989. And over all this time, we've really been seeing AI slop taking over the forums. A few months ago, there was a guy on the main Kryptos group just came and posted some very complex idea that sounded like, he was using technical language, and, well, maybe he knew what he was talking about, but the algorithm didn't really make any sense, and when people challenged him, he was clearly just copying their replies back into ChatGPT and then copying that reply as his reply, and it was really quite ridiculous. It was like, didn't he think that people would see what he was doing? So what immediately came to mind for me was it has serious implications for something like the Histocrypt conference. So I'm currently the secretary of the steering committee for the International Conference on Historical Cryptology, Histocrypt, which is held in Europe every year in June. Since 2022, the NSA Cryptologic History Symposium in the US hasn't been held. And it seems unlikely it's going to be held again. It was facing funding challenges, but also from the perspective of non-American people, visa issues made it hard to attend, versus as an Australian, I've been able to attend several Histocrypt conferences with no issues. This year, the symposium cancelled the whole conference with about 2 months' notice, and many people said they wouldn't be attending again no matter what. Everybody involved with Histocrypt is like a volunteer of some sort, or an academic. Nobody has any time to review AI slop. And if we suspect anything like that is happening, we'll have to just, reject it outright. Obviously, that's just for Histocrypt, and this sort of thing has serious implications for society as a whole. Along the way, I learned I was wrong about the Binninger Berlin clock. I said there's no time during the day when all the hour lights lit up, but that's wrong. Between midnight and 12:01 every morning, all the lights light up for a minute. I get emails from people, and after applying some sort of Dunning-Kruger syndrome filter, they and the group posters or the red posters, they usually have a few flaws. The first one I've often talked about is they don't try to measure the likelihood of their findings. That is something that chatbots, large language models, can be helpful with. If you can turn off the sycophancy, you can have them do stats and charts, and I'll be talking about that a bit later. The second thing is they don't have a good sense of how difficult a classical cipher is to actually solve at a given length. And also I see that their suggested methods are just far too complicated. If their suggestion just has a few more sentences, then it's very clear that nobody is ever going to guess that, especially not knowing any of the crypts. And yet, given it's been unsolved for so long, the K4 method seems like it must be quite complex. As soon as the method passes some level of complexity, there's a paradox. Either it becomes unfair as a challenge, or it's very error-prone for pen and paper enciphering or deciphering. Obviously, Chaos Cipher was both, and the challenge setters for that should have known that and disclosed that. You remember I talked about the Kryptos Society newsletters. The advice for cryptanalysis there was data quality is important, and know the quality of your data. I think we've seen some pretty bad cheats there from Sanborn, and there's a quote there, K4 is a solid system and I fucked with it, from August 2025, which again doesn't inspire confidence. And we see something there, watch D's and O's on the K3 worksheet there, from the Nova television program. In the auction photos, we also see that he said there's two systems of enciphering the bottom text, and yeah, there's two separate systems, and maybe that means that there isn't really another system in there. It's just a combination of the existing ones. I posted some of the links to the Hacker News website, and there are some insightful comments there. Somebody said if a puzzle has gone unsolved for 35 years, despite many skilled people trying to solve it, it's not actually a good puzzle. Jim wasn't a cryptographer, he might have gone buck wild with this encryption. And another person independently says, it's simply a poor puzzle. Everything reasonable has been tried eliminated, which means only unreasonable solutions are left, which is fair enough. But I'm still going to say, despite that, I'd say that one system stands out above all the rest, and it does combine all three of the 1999 suggestions of Jim Gillogly. That's running key, auto key, and transposition and then substitution. Now, before we go there, I'll just point out in terms of the difficulty level at this length, running key or auto key with unknown alphabets, whether it's plain text or ciphertext with unknown alphabets, it won't be solved now or ever. And people have also brought up the idea maybe it's some kind of book cipher with take the English text and apply some sort of transposition or substitution to get the key we've seen. That will also never be solved, just like the famous decipher puzzle. And even running key with non-alphabets can't generally be solved at 100 letters, which is the length we see in K4. And I'd suggest you look at those references if you'd like to know more detail. So to look at the visual clue, the implied key, the visual clue on the original sculpture, not Antipodes, is that you look at these red letters at the edge of K4, you see KRSOYP on the right hand side and you see a T on the left hand side. And so the implication is the cipher is so complicated that it really flattens the frequency of the letters. So an equivalent way of saying that is it has a low index of coincidence. And yet you can put those letters in somehow. It's simple enough to just be able to choose those Kryptos letters on the edges. Now, if you use the same substitution method as in the first two parts of Kryptos, the implied visionary key for the known plain text we've been given, that's east, northeast, and Berlin clock, is this yellow and red text here. And the question is, what is that? Is it purely random, in which case it's like a one-time pattern and will never be solved? Is it pseudo-random? So there's a paper by Jim Reeds in Cryptologia in 1977 about how to break that sort of thing. Gromark is one example. Or is it possibly transposed English? And if it's a pseudo-random method, they're often too mathematical, like Gromark, to be taken seriously, or you'd spot them, like Weimark, which is like a base 26 version of Gromark. But if it is transposed English, the question is, where does that English come from? So let's take a look at some visualizations of where this sits in the statistics of English. And now the famous book, How to Solve It, talks about drawing a figure. So these are two different ways of measuring whether a chunk of text is English. You've got a chi-squared statistic on one dimension, you've got a G statistic on the other. And that yellow star there is where this RDUM text fits in compared to random text, which is all the red dots, and English text, which is all the blue dots. Now, it really needs a third dimension of frequency, but it is basically right on the edge of both of them. So it's not impossible that this is transposed English of some sort. And here's another visualization. Looking at the key fragment Englishness. Now, obviously, I've had ChatGPT help me on both of these to write the Python code to do it. So this big blue ellipse is based on the implied key text ELYOIE of length 6, and this blue X is where that implied key sits in terms of 99% of English text analysed. Okay, and then as more of that key is released, as more plain text is released, I should say, and we can derive more of the implied key, that ellipse gets smaller and the X moves relative to that ellipse. So by the time 24 letters are released, we've got this red ellipse here. Those contour lines are for the 99% of English text, and the red X sits just outside it. So from that perspective, it's still quite possible that this, could be transposed English. So my guess is that the implied key is just transposed English, and the key is simply the transposed plain text. So you're solving effectively P plus P transposed is the ciphertext, you know what the plus operation is. It's just visionary addition using the Kryptos alphabets for plain, cipher, and key. You know what C is, the 97-letter text. You don't know what T is, the transposition, and you don't know what the 97-letter English text P is. And you can look at that in two ways. You can say this is running key with extra constraints, or you can say this is a variant of plain text auto key, so PTAK. So let's look at the arguments for and against that. The four arguments are that this helps account for the very low index of coincidence, the flat frequency distribution. It's kind of a pseudo-random key, so it lowers the index of coincidence. The key does look like English, and other people have had this idea of a transposed English key. So Christine Seaman, I mentioned in my last talk. I would say it helps account for the Kryptos letters down the side. If you know what the transposition is, you just have to pick other letters in those key places to get that. Whereas this is an argument against Gromark. I think it would have been difficult to get those letters down the side in 1988. I think it accounts for the bias of the Kryptosy letters at the start of the Kryptos alphabet and the current implied key. It is in the ballpark of eventually solvable, maybe mid-21st century solvable as well. It accounts for the 24 plain text letters revealed, not helping very much. It accounts for a non-mathematical method, and it's a thematic link to the first three parts of Kryptos. And the creators can't seem to give a straight answer to does the method use transposition, because it does and it doesn't. It's definitely more than one stage, like Edward Scheidt said in 2015, and it fits in with just two systems, like we saw in the auction text a few slides back. Now, a transposition splits the plain text into cycles, and this is very easy to solve if you just know one letter per cycle. So, for instance, in plain text AutoKey itself, you have a primer, maybe it's just one letter, and with knowledge of that primer, you're enciphering the plain text with the plain text itself shifted, basically. Now, the strongest argument was possibly this one, but I'm not sure if it's pareidolia, like if I was just imagining something. So beginning the solution process without any cribs, I maximized the statistics of the plain text, and I saw in one of the answers using just 3 gram statistics, I saw 7 out of 24 letters matching without changing anything. So THEAS in the right place and IN in the right place there, which I thought was pretty incredible, but it's hard to say whether that really is the highest 3 gram score out there. It's a very difficult problem. Now the against arguments. Frank Lewis said in solving cipher problems, plain text AutoKey is very error prone. Obviously, if you add a transposition step, it's even more so. And if Sanborn decided to introduce a very complex transposition, K4 is probably unsolvable. This is still a very low index of coincidence, and the ciphertext index of coincidence is more likely to be this low if the plain text index of coincidence is low. So if it's around 0.05 and you encipher the plain text with it self-transposed, then you're more likely to get this very low index of coincidence of the ciphertext. Sanborn loves to talk about matrix codes. 97 is a prime, but it wouldn't give a matrix like these other numbers would. But if you did use a matrix, it's going to add even more complexity, and then solvers would still have to guess what was done. I have to say that's rather unlikely. Now, is he working with the original 97 letters, or are there one or more letters out the front where the question mark is in the ciphertext? And there's one other thing he could do, which is insert a question mark in the plain text at any position. That makes it 98 characters. do some transposition, and then remove the question mark to make the plain text and the key 97 letters for the enciphering step. As an illustration of the cycles that a transposition can split plain text into, there's two route transpositions used in K3, and here's a visualization of the two cycles that it splits the plain text into. So you can't really see a pattern in there. It just looks like a real mess. So that was a bit of a surprise to me. If you use the running key solver algorithm of Griffin with 7-gram statistics on K4 itself with the Kryptos alphabets Visionaire edition, then you get solutions like this. So you see at the end we have ION, and then in the key, either of these could be plain text key, could go either way around. You see ION in one of them and ETH in the other. And so at the end, if you add these together, you get KCAR. And you need quite a lot of RAM to solve this, so you need a computer with at least 300 gig of RAM. Whether you solve it going from left to right or right to left, you get quite a bit of overlap. So you can see you've got thrown beaver in both of them, and the ION there in both of them. Concept, the many concept. It goes quite a long way back there, the overlap. If you began with 7-gram statistics, you can see things like if T with the clearly can't be the beginning of a real English text. But if you were only looking at the initial 7 letters of English sentences, then you could get something like King SHA plus on a hill is the initial 7 letters of Kryptos. And somebody's actually noticed that independently in the Kryptos group a few years back. But it's really not that strange, because these 7 grams here, they're in the top 90,000 7 grams, and 90,000 squared is about 26 to the 7th, so you do expect things like that to happen. So one idea is you could say on a hill is the initial key, and then derive the next 7 letters a key by transforming those somehow. And we see that an 11-letter key is an 11-letter plausible beginning for this is leeward key, which has been seen in other places on the internet, certainly been seen before. So the straightforward solution attempts are if you have P plus P transpose equals C, well, just guess T. And if it's intended to be keyword based and solvable in 1990, then columnar transposition is the most likely candidate. And if it's like plain text auto key, perhaps you add the keyword before the plain text itself, do a dictionary search. Maybe it's based on route transpositions like K3, but then you probably need a matrix. And there's other ideas like rail fence or affine shifts, things like that. There's another idea, which is a very good use case for chatbots. You can use the optimization solver Gurobi, and you can just say to the chatbot, write me Python code which solves this problem using Gurobi, and it then produces a mixed integer program, and the objective function is trying to maximize the sum of the scores from the putative plaintext, not minimize. And the constraints ensure that the key and the plaintext are permutations of each other. There are a lot of binary variables there, basically. And so you take Gurobi and you can solve it with 1 gram statistics very quickly, get the cribs in place as fast as possible, and then solve it with 2, 3, 4 gram statistics to get better and better solutions. But this is very slow to improve, and there's still a huge solution space, So it's better to use a simulated annealing approach and do random transforms of the key, which is basically the way the Playfair solvers work. So here's some example solutions to show you that it doesn't really converge. The best solution with 6, 7 and 8 grams statistics is something like this. It's got east-northeast riving yaws and the Disso entry by Berlin clock, always tanned and is now, it doesn't make a lot of sense. But you do see that it is moving some rubbish to the beginnings and ends. You've got KY at the beginning and you've got WQ at the end. And then the rest of it makes sense as blocks of English text by itself, but it doesn't make any sense as English. And you really don't want to see solutions with at least or their feast or things like that. But you would be okay with other Berlin clock if you had they Berlin or Theo Berlin. That's obviously really unlikely from the perspective of humans. For the 9 gram statistics, you start to get a bit more English text. Still doesn't make a lot of sense. You've got Berlin clocks that monitor any kind. With 10 grams, you obviously start to see even more, but it doesn't make any sense as an actual sentence. During your king, the inside of the Berlin clock make money or anyway. It's still moving rubbish to the beginning and the end, and it's obviously got in its statistics the Berlin somewhere that it thinks is a useful, commonly seen 10 gram. I wouldn't, mind seeing it end in information. That would be nice. But to get rid of this problem of the rubbish being pushed to the beginning and the end, what we had to do, Louis and I, in the Playfair challenge, was use positional n-gram data. But it's not converging with this method anyway, so there's not a lot of point in spending much time on it. I did notice that at the beginning there was one meaningful 12 gram scene, which was in a barely dis, but even forcing that, you don't get terribly meaningful English text in a barely distort earth, east-northeast, Henning Gion in the right, and then Berlin clock, my men on yours a day was, it doesn't make any sense. The way this works is educational when we look at where the K's come from. So if you see one of the 8 K's in the cipher text, it can be A plus N, I plus E, K plus K, because K is a 0 and K plus K is 0 plus 0, or it can be U plus O. So to improve this, solving it this way, perhaps it needs word scoring to improve it, but it would be hard to maintain the invariant, and it wouldn't work in a mixed integer program. So it'd be quite difficult to solve this way. So the final conclusions are the trajectory of K4 is starting to follow the infamous chaos cipher challenge very closely. Sanborn's coding charts are sloppy. We've seen strange shite statements from Ed Scheidt, the co-creator of Kryptos, in the last talk I gave, and none of this is inspiring confidence at all. If I had to bet, I'd now say I'd come down very strongly on the not a fair challenge side, but I'd also guess that this idea of the plain text transpose being used as the key idea would be the most likely idea. I think anything harder than that would be just absolutely impossible. So why can't people solve it? I think either there's been some sort of error, some sort of handwriting problem, or Sanborn went buck wild with the encryption. I wouldn't have bid at the auction, and I think it was on very shaky ground even before the revelations. From a personal perspective, Kryptos did get me back into the joy of amateur cryptanalysis with the Thalos cipher, the IRA cipher, Biafran ciphers, Arthur D, Emperor Rudolph II's handbell, the CIA sealing cipher, and lots of others, writing about it and going to Histocrypt conferences and helping out with that conference. And if you're willing to learn, that can teach you the power of and the limitations of modern chatbots. You get better results saying, write me a program to use a tool to solve the cipher, but you'll never get a result just by typing the cipher in and saying solve it. And anybody who understands the limitations of chatbots should understand that. You can look then at that program that's generated. You can carefully verify it for correctness. But unfortunately, chatbots are leading to serious issues in science and education and in society generally, and I don't have the answers for that, unfortunately. Maybe we should just, of course, go back to pen and paper exams and I don't know, be very careful in how we assess things for conferences, but it's a challenge for all of society. Okay, thanks.